So here is our main shape of this whole chapter is a parallelogram. And the reason that we chose to jump from chapter 3 to chapter 6 was because everything in chapter 3 was about parallel lines, and everything in chapter 6 is about parallelograms, and so we wanted to keep those together. A parallelogram is a quadrilateral, meaning it has 4 sides, a quadrilateral with 2 pairs of parallel sides. 2 pairs of, I'm just going to abbreviate, parallel sides. You've learned this shape probably as far back as elementary school. Parallelogram has opposite sides parallel, so those 2 sides are parallel, and then they put double angles or double little arrows there to show that those 2 sides are parallel. Parallelogram. There are 4 main properties of a parallelogram, and they really are easy to see with the picture. What do you think about the opposite sides? Like, how long do you think side JK is if side ML here is 6? You're right, 6. How about the side KL? Well, I bet that matches too. Yes, 4. The opposite sides of a parallelogram are always equal. And they're going to look equal, right? So we might have like a little algebra problem where these 2 sides are equal. We'd have to write a little equation. 3y plus 1 equals 19. Okay, I get it. Y is 6. And that's okay to subtract 1 from both sides in your head, divide by 3 both sides in your head, and then similarly the 22 is going to equal x minus 1. Maybe I'll show that work here. So x equals 23. And that's about as hard as it gets to showing opposite sides of a parallelogram are equal. Now the next one we have actually kind of talked about already in chapter 3. We talked about the opposite angles of a parallelogram. Oops, so I'm going to pull it down a bit. So the opposite angles of a parallelogram. Remember in chapter 3 we said like, okay, if this angle is 120, that the one opposite it is also 120. So the opposite angles of a parallelogram are equal. Or in a little algebra problem, maybe 6x plus 18 equals 72. And I would subtract from both sides. So 54, so if I divide both sides by 6, x equals 9. Opposite sides are equal. If I want to find the other 2 sides, do you remember how we do that from chapter 3? These are really same side interior angles. Same side are supplementary, so we're going to subtract from 180. Or we're going to say that the consecutive angles are supplementary, which are really just the same side interior angles. So here we filled it in already, like those 2 are 50, opposite and equal, and then these 2 are 130 because they're supplements to 50. So here, let's see, if I wanted to solve this one, like maybe I'd solve for y first. 8y minus 2 equals 70, because the opposite angles are equal. Y is 9. And if I wanted to solve for x, I would look at these 2 next to each other and say that those add up to 180. So 2x equals 110, so x equals 55. Consecutive angles are supplementary. The last one talks about the diagonals of a parallelogram. So we learned yesterday diagonals kind of connect the corners not next to each other, and I'm kind of actually going to erase that because I'm crossing out the lines here. The little lines are showing me the rule. Those 2 segments are equal, these 2 segments are equal. Or we say the diagonals of a parallelogram bisect each other. Bisect means cut in half. Bisect each other. So here, like these 2 little guys are going to be equal. So y plus 1 equals 16, y equals 15. And similarly, these 2 guys are equal, the 2x and the 14. So x is 7. Okay, so now at the end here, we put it all together. And just like we do a lot in this class, we're going to write all our answers, as many as we can, on the picture, and then do it on the actual answer blanks. And I'm going to do the sides first, because the sides are easier. I notice this side is 10. This side up here is also going to be 10. This side is 7. This side is 7. So here, those questions are asked over here. DC is 10 and BC is 7. The next ones are the diagonals that they give me. So 4 is going to match 4. So OB here is 4, making DB 4 plus 4, or 8. And then 6 here is going to match 6 here. So AO is 6 and AC is 6 plus 6, or 12. So we got 10, 10, 7, 7, 4, 4, 6, 6. Everything kind of matches. I'm going to erase that now, and I'm going to do the angles, because the angles are a little trickier. So I see this 40 and 15 here. One thing I notice that you're going to see in a lot of parallelograms are the Z's. So there's going to be another 40 here, and similarly there's going to be a Z here for the 15 there. So let's see if that was asked at all. Let me see. B, C, D. Oh, let's go. I should have actually maybe looked at the question. D, A, B. D to A to B. That's this big angle here. This big angle here is going to be 55. 40 plus 15. This big angle here on the other side is also going to be 55. So did they ask for that? B, C, D. Yes, they did. 55. And then now if I say ABC, ABC is over here. Well, if that's 55, sometimes it helps to draw it kind of blank. So the big corner angles we said are 55, A, B, C, D. Now it's asking for this angle, this big angle. How would I do that? Right, 180 minus 55, so 125. 125. So ABC is 125, CDA 125. So I guess they never asked me about this little baby 15 and 40, but that's coming up anyway, so it's probably a good preview. So here are the 4 properties of a parallelogram.